Hey guys, this is our first set of notes for our Unit 3 on trigonometry. You can go to your new digital notebook and put your name on there. You can go to your table of contents, fill in our slide number 6 is going to be right triangle review. So this isn't technically in the Integrated Math 3 book, but it's something that we should review before we get on to the rest of our trig stuff. So today we're going to take some notes on right triangles. So our right triangle review notes. You don't have to write down the essential question. As always, it's on the slide when we put it on our into our slides presentation. But we want to know, how do you find a missing side or angle in a right triangle? So a reminder of what a right triangle is. A right triangle is just a triangle with a 90-degree angle. So the way that you show that a triangle is 90 degrees is you put this little box in the corner that signals, that's the representation that it is a 90-degree angle. Across from your 90-degree angle, this side is called the hypotenuse. And the other two sides are just they call them legs. So you just have two legs and a hypotenuse. So something that you guys hopefully have ingrained in your brain is the Pythagorean theorem. So the Pythagorean theorem, you're able to find a missing side when you already know the other two sides. So the Pythagorean theorem is good to find a missing side when the other two are known. So you might know both legs, you might know one leg and the hypotenuse, but you have, in order to find the missing side, you have to know the other two. So again, it's a right triangle. The Pythagorean theorem, hopefully you guys remember it, is that a squared plus b squared equals c squared. The thing that you need to remember though is that the c is always your hypotenuse, and then the a and the b are your two legs. It doesn't matter which one's which. You just plug them in and solve for the one that you're missing. The other thing we need to talk about is just the triangle sum. The triangle sum is just that the three angles in a triangle add up to 180 degrees. So if it's a right, it doesn't matter if it's a right triangle or not, actually. The angles could be whatever they are. And if you added those three angles together, you would get 180 degrees. All right, next up we're going to talk about excuse me, the angle of elevation and depression. And I'm going to do a little drawing right here. Please don't judge me on my drawing skills. The angle of elevation and depression. So I'm going to draw a little building. And it has some windows, right? Okay. So say somebody was standing on the ground and somebody was standing at the top of the building. The person who is at ground level, if he looked up to the person that's at the top of the building, that angle that he forms is the angle of elevation. Because he's elevated. He has to look up. The angle, on the other hand, from the guy that's at the top looking at his friend at the bottom, his angle from what he forms is called the angle of depression because he has to look down. Those two angles are equivalent, which means they're the same. Sorry, I shouldn't be coughing, but I can't edit it out. Okay, so this picture is going to go on one side of our slides. Presentation is half of our notes. So this is all right triangles we're talking about, except for the triangle sum, I guess, and the angle of elevation, depression. Use those usually with like word problems, okay? All right, the next thing we're going to talk about is Socatoa. So hopefully you know about the three trig ratios, sine, cosine, and tangent. So when you hear of what that means is that the sine of an angle, right, the ratio from the opposite over the hypotenuse will always be the same. So no matter, if the triangle had, so don't draw this or anything, but the triangle had like a 30-degree angle. Here's the opposite, here's the hypotenuse. It doesn't matter if it's that angle or this big old triangle with a 30-degree angle. The hypotenuse and the opposite, the ratios are equal. So maybe this was 1/2 and this ratio was 2/4, or maybe this ratio was 5/10. It's always the same. So even though that triangle is bigger, the ratio of the opposite side to the hypotenuse side is always going to be the same. So we have sine, we have cosine of an angle is the ratio of its adjacent over the hypotenuse. And then lastly, we have tangent of our angle. The ratio is equal to the opposite side over the adjacent. Okay, so let's talk about how to find a missing side. So how to find a missing side when you are given one angle and one side. Okay, so here's our little triangle we're going to draw. We're going to show that it's a right triangle. We're going to be given that this side is 30, this side is the one we're trying to find, and this angle right here is 50 degrees. So this is not drawn to scale. Okay, so we're trying to find a missing side, so we're trying to find this side right here, x. We were given one angle and one side. Okay, so we're going to use that information, the one side and the one angle, to find the missing side that they want. So we're going to write down some steps. These steps are going to help you guys later on, like when you're doing your homework and everything. So the first step, the first thing you want to do, I'm just going to kind of write them off to the side, and then we'll show our work in the middle. The first step is you want to label your angle as theta. And the two sides. Okay, so what I mean by that is I go and I call my angles 50 degrees. I'm going to call that theta. With respect to theta, x is the opposite. It's opposite the triangle from the angle. And the 30 degrees is opposite of the 90 degrees. So that one is the hypotenuse. So that's your first step. You want to label your angle as theta and then label your two sides. So you're either going to be the hypotenuse and opposite, the opposite and adjacent, the adjacent and hypotenuse. You're just going to label them. Step 2 is you determine which trig ratio to use. So since I have the opposite and the hypotenuse, the trig ratio that uses the opposite and the hypotenuse is the sine ratio. So that's the one I'm going to use. So the way that you decide is you look at which sides did you label. Okay, did you label the opposite and the hypotenuse? Did you label the adjacent and the hypotenuse? The opposite and the adjacent, which ones did you label? And then that's the trig ratio you want to use. So we're going to use the sine ratio. So sine of theta equals opposite over hypotenuse. And we're going to plug those pieces in, right? Okay, so we're going to plug in sine of theta. We know theta. Theta is 50 degrees. The opposite is what we don't know, x. That's what we're trying to find. And then the hypotenuse is 30. We do know that one. Okay, so then step 3 is to go ahead and fill in the pieces. And then step 4 is you're going to have to solve for x. And this is where you're probably going to need a calculator. Okay. All right, so let's go ahead and solve for x here. So we have sine of 50 degrees equals x divided by 30. That's what this line means. So the way that we get x by itself is we have to multiply both sides of our equation by 30. That's going to cancel, and it's going to leave x all by itself. This right here is where we're going to have to use a calculator. So if you have your own calculator, like a TI something or Casio or something, you can type it in. If you are using your iPhone, I highly suggest using the Desmos app rather than turning your calculator sideways for the scientific one. If you use the Desmos app, first thing you want to do is check the settings. That's this little wrench up here. And then you want to change it to degrees, because that's the mode that we're in. So you go to little wrench up here, and then you hit degrees. Make sure it's in the green. And then we can just type in what we wanted to do. So it was 30 times. The way that you get to sine is you hit this functions over here, and then it's already it's already on trig. So then I just put sine, and then we do 50, and we get our answer, 22.98. I didn't tell you where to round or anything, but 22.9813332936 is too much. So we're just going to do 22.98. So our x is 22.98. We don't know the units, if it was inches, yards, feet, or anything like that, but 22.98. Okay, so we have our steps there to hopefully help you when you're working on your problems. All right, let's talk about how to find missing angle. So that's how you find a missing side. Okay, so missing side. Now we're going to talk about how to find a missing angle if you are given two sides. Okay. So our triangle that we have, we're going to set up as a right triangle. So we put our little box right here. And then we're going to have this side is 10, this side is 30, and this is the angle we're trying to find. All right, so our steps are going to be really similar. Okay, the first step is you're going to label your angle as theta and the two sides. So for ours over here, my angle, I'm going to label as theta, and then I'm going to label my two sides. Well, the 30 is the hypotenuse because it's across from the 90 degrees, right? This side over here would be opposite of our x, so then this side is our adjacent. It touches our angle, right? Our angle touches this theta, this side, so it's adjacent. All right, now that it's labeled, then we have to determine which ratio to use. So since we have the two pieces that we have are adjacent and hypotenuse, okay, we have adjacent and hypotenuse. Which of the three trig functions uses adjacent and hypotenuse? Cosine. So we're going to use cosine to set up our trig ratios. Okay, so we're going to use cosine because the reason why is because cosine of an angle is equal to the ratio of adjacent over hypotenuse, and those are the two sides that we were given. So I'm going to go ahead and for step 3, I'm going to fill in the pieces. And my pieces are cosine of theta, well, I don't know theta, that's x, equals adjacent is 10 over hypotenuse is 30. All right, so then step 4 is going to be to solve for x using the inverse. And for this, you're going to need a calculator as well. All right, so what we need to do is find x. That's our goal. Okay, our goal is to find x. Currently, x is attached to cosine. Well, we can't just add cosine or subtract cosine or do anything. The way that we cancel cosine is we use its inverse. Okay, so the way that we cancel cosine is we have to use its inverse. So we take the cosine inverse on both sides. Here, let me write that a little bit better, or a little further down. So we take the cosine inverse of both sides. And what happens when you do that is that the cosine inverse of cosine cancels out, and you're just left with x equals, and we're just going to go ahead and plug this into the calculator. Okay, so we're going to plug in cosine inverse of 10 divided by 30. So I'm going to go back to Desmos. I highly suggest that over using like your iPhone calculator turned sideways. And we're going to type in cosine inverse. When you get to that, first make sure we're in degrees. We go to the little wrench, make sure it's in green. And then we type in functions. It's already on trig. We go cosine inverse. It looks like cosine to the power of -1, but you read it as cosine inverse. And then you just do 10 divided by 30. Went into the fraction. We get 70.52877. It didn't tell us where to round or anything, so we'll just use 70.53 because that would be 2 decimal places. So our angle is 70.53, and it's degrees, so we put that little symbol right there. Let me move my x maybe a little further down. So x equals 70.53 degrees. Okay, so the way that you find a missing angle is you can follow those 4 steps. You're going to have to use the inverse. It looks like to the power of -1, but you read it as inverse. All right, where these notes are going to go in your digital notebook, okay, I just have 2 pictures that are going to go in on slide number 6, and that is it for our notes of review. You're going to go do some practice for homework.